What if I can tell you that if you combine multiple robots, such as a lower limb exoskeleton, an ankle exoskeleton, and a small walker, you can create a robotic multi-platform with advantages over people with disabilities. This is the Agora platform, composed of these three devices to provide support and rehabilitate people affected by neurological diseases. Our work is about exploring multimodal gait rehabilitation and assistance through an adaptable robotic platform. As background, stroke is the leading cause of long-term disability, where 80% of stroke survivors exhibit walking dysfunctions dificulting their ability to perform activities of daily living. A stroke can cause hemiparesis, where it affects one side of the body, producing muscle weakness, and rehabilitation process can include the assistance of robotic devices so the person can recover their normal gait, autonomy, and confidence. Lower limb exoskeletons can improve the quality of rehabilitation exercises and also accelerate the recovery process. Robotic walkers can allow higher levels of autonomy for people suffering from stability impairments, providing balance and stability. Combining these devices can provide better lower limb rehabilitation, where it has been proven that exoskeletons that assist multiple joints can generate more significant metabolic savings than those assisting a single joint. And the use of a small walker can ensure proper lateral balance and stability. Even though there are platforms that allow the integration of multiple devices, such as Locomat and the CP Walker, they are usually tested as a complete system and do not provide modularity. From the clinical point, it is desirable that rehabilitation tools offer adaptability according to the impairment level of the patient. To fulfill this, the Agora V2 platform is created, which is an adaptable and modular system that provides multimodal physical and cognitive support in post-stroke rehabilitation scenarios for patients with hemiparesis. It consists of the Agora V2 unilateral lower limb exoskeleton and the Agora V2 smart walker. The methodology includes the Agora V2 unilateral lower limb exoskeleton to assist hip, knee, and ankle joints through stiff and compliant actuators, and the newest version of the Agora walker, which is the Agora V2 smart walker, to compensate the kinematics of the person and generate greater impulse forces on the device. For this, 14 healthy volunteers participated in the study. They were instrumented with electromyography surface sensors to evaluate muscle activity at 4 relevant muscles in the gait activity, and inertial measurement units at the tip of both feet to analyze gait parameters. They performed the maximal voluntary contraction of each muscle and performed a 10-meter walk test over ground in straight line for 4 conditions. The first one is an evaluation without the robotic devices. The second one, an evaluation with the Agora V2 unilateral lower limb exoskeleton. The third one, it is an evaluation with the Agora V2 small walker. And the fourth one, the evaluation of the complete Agora V2 platform. As a result, in the muscular activity, there was a reduction of muscle activity in muscles responsible for hip flexion and knee extension when comparing the condition without devices and with any robotic device. There was also a reduction of muscle activity in the rectus femoris and vastus lateralis when comparing with the exoskeletons and with the complete platform, indicating the importance of combining the exoskeleton with the robotic walker. There were also results obtained for the controller indicators, where the walker's admittance controller takes the impulse force in Y of the user. Also, the exoskeleton properly uses the gait phases as an input for the knee, hip, and ankle joints. The complete platform induces slower gait patterns as the impulse force and linear velocity decrease, occurring due to the velocity constraints of the exoskeleton, which could guarantee a safer interaction in pathological patients. For conclusion and future works, This work, the Agora V2 platform can present different models evaluated separately and combined, and it can be adapted to the patient's level of disability to have more control in their rehabilitation process. Also, it allows the clinician to make decisions and configure the platform according to the therapeutic objectives of each patient. And future works will focus on studies with pathological patients to evaluate the platform's performance on users with mobility and stability limitations, where these results of the study can be taken as a baseline. See you there. Thank you so much.